ओके अब चलते हैं अल्टरनेटिंग करंट लेसन 34. The theory part we have already covered and have done many numericals also. Let us do 4 quick numericals. Number 1. In an AC circuit, alternating current means where the EMF and the current changes with time and the direction changes periodically. V and I are given the voltage. You can write V, you can write E, no problem. V is written as 100 sine 100 t volt and I is written as current, instantaneous current at a time t, 100 sine 100 t plus pi by 3 milliampere. Careful, here it is volt, here it is milliampere. So you have to be careful when you see such things. You have to convert this to ampere. Then the power dissipated in the circuit will be how much? 10 to the power 4, 10 or 2.5 watts or 5 watts. Now if you compare these two, this voltage with the equation E is equal to E naught sin omega t, I had used the expression symbol E naught. It is in the question, it is given as V. So no matter, doesn't matter. EMF is same thing as voltage, which I have explained in current electricity, is the maximum value of the voltage across two terminals of a cell. If you compare this with E is equal to E naught sin omega t and this expression for current I is equal to 100 sine 100 t plus pi by 3 with I is equal to I naught sin omega t plus 5, then the conclusion is your E naught is your 100 volt. E naught is 100 volt and your I naught is 100 milliampere. 100 milliampere, not ampere. So I convert this to ampere. So I convert this to ampere. So it becomes 100 into 10 to the power minus 3. Compare this with V. Your E naught is 100 volt. E naught is 100 volt. Compare this expression for I with I is equal to I naught sin omega t. So your I naught is equal to 100 milliampere. So that is what I have written. I naught is 100 milliampere. That is 100 into 10 to the power minus 3 ampere. And if you compare this sine omega t, sine 100 t, so your omega is equal to 100. We don't require it. So omega is equal to 100 radian per second. This is the unit of omega, angular velocity, angular frequency, you can say, not velocity because we are not doing kinematics. So we don't require this, we don't need this term here, but just for sake of understanding I explained how to compare and find out. And what is the phase difference? Between the voltage and current plus pi by 3. Current is ahead of the EMF, the voltage by pi by 3, that is 60 degrees. So phi is equal to pi by 3. Now we had derived in our alternating current lessons, previous lessons, the power consumed was P was E naught over root 2, I naught over root 2 cos phi, where this was called power factor. E naught is given, I naught is given as 100 milliampere, root 2 cos pi by 3. So just put the values. So root 2 into root 2 becomes 2. This is 10 to the power 4. This 10 to the power minus 3 cos pi by 3, that is cos 60, that is same thing as half. So we get 10 by 4, that is 2.5 watt. Okay, so then coming back to the second one, now you will find it easy. Second one, there is a capacitor of 1 microfarad. The capacitance of the capacitor is 1 microfarad. And for example, for a parallel plate capacitor, we had derived this expression. In electrostatics, C was epsilon naught A by D. Epsilon naught is a constant. If the between two plates there is vacuum, then epsilon naught. A is the area of the plate, D is the distance between the plates. All these things are, once the capacitor is manufactured, these things are constant. So C is a constant. A capacitor of 1 microfarad initially charged to 10 volts is connected across an ideal inductor of 0.1 millihenry. The maximum current in the circuit will be how much? There are four choices: 0.5 ampere, 1 ampere, 1.5 ampere, 2 ampere. Very simple. We can straight away use the conservation of energy, but let me explain certain things that we studied before. Energy of a capacitor U was derived as half CV square. C is a constant. So, as the potential difference V across the plates of the capacitor increases, the energy also increases. Now, how V will increase? We know charge stored in a capacitor is C into V. So, from this, your V is equal to Q by C. It's a fraction. C is a constant. This is a fraction, numerator, denominator. So, if Q increases, so V also, potential difference across the plates of the capacitor also increases. So, as you charge the capacitor for more and more time until it is fully charged, as Q increases, V increases. Since V increases, therefore this term also increases. That is, the energy increases. Now, that is what I explained. As Q increases, V increases, because V is Q by C, C is a constant, this is a fraction. If the numerator increases, the value of the fraction will increase. Therefore, U also increases because V is increasing. So energy of the inductor we also know, half Li square. The capacitor was initially charged and then it was connected to the inductor. Now, having inductance L, which is given as 0.1 millihenry, 0.1 millihenry. So, here the capacitor is charged to 10 volts, not more than that. So, I take it as maximum, that is V naught. I call it as V naught, that is 10 volt. So, by conservation of energy, now energy of the capacitor will be available across the energy of the inductor. I had explained you before, when there was a capacitor like this in parallel LC circuit and an inductor like this and was connected to an alternating source of EMF. The capacitor was charged and at this frequency, at nu is equal to 1 by 2 pi LC square root of this, this capacitor and this inductor were not drawing any current from here. The current from here was 0, that I had explained in previous two relations. So the energy stored here will be available across the inductor. Again, the energy stored here will be available across the capacitor. Again, the energy stored in the capacitor will be available across the inductor. This energy, this transfer of energy from capacitor to inductor, from inductor to capacitor takes place at this frequency, right? So, that is what we had studied. So, by equating these two, and we are interested to find out I naught. So, I keep I naught one side, half cancels. So, I keep I naught one side, half cancels. So, V naught square over square root of that. I put the value of capacitance because this is given. Voltage 10 into 10 divided by L was 0.1 millihenry. So, just simplifying, I get it as 1 ampere. So, the current through the, so the maximum current in the circuit is 1 ampere. So, then let us come back to the third one. Very simple. What it is, the power factor of the circuit zone. There is a circuit zone here. Here is an inductor. Its resistance is 100 ohm. Means XL, which was equal to omega L, is 100 ohm. And the resistance of the capacitor is 50 ohm. Resistance of the capacitor was written as XC, was equal to 1 by omega C. This value is 50 ohm. And the resistance of this resistor is 50 ohm. So, they are in series. So, series RLC, or you can say LCR, doesn't matter. Now, what is the power factor? Power factor I have derived you. So, these are the four choices. What is given? XL, that is omega L is given, XC 1 by omega C is also given, resistance is given. Now, from the impedance triangle, I had explained you this right angle triangle. This side was representing the resistance R of the resistor. This side was represented by the combined effect of the inductor and the capacitor was XL minus XC, and the hypotenuse was your total resistance called the impedance of a RLC series circuit, and this angle was phi. So from here your tan phi will be perpendicular by base. So your tan phi will be XL minus XC over R, that is 100 minus 50 over 50, that comes out to be 1. So in tan table, in the trigonometric table of tan function, where do you come across 1? If phi is equal to pi by 4, that is 45 degree. And we are asked to find the power factor. And our power factor was cos phi. From this expression, P was equal to E naught over root 2, I naught over root 2 cos phi. So this was called your power factor. So we have found out phi, pi by 4. So cos pi by 4 is 1 by root 2 is your power factor. And I had also explained you a circuit containing inductance only, a coil only. This phi was pi by 2, cos pi by 2 is 0, 0 into this thing is 0, so power consumed is 0. Similar, a circuit containing only capacitor, this phi, the phase difference between the voltage and current, was also pi by 2, cos pi by 2 is 0, 0 into this thing is 0, so the power consumed is 0. This is just to revise you, means a pure inductor connected to AC source does not consume any power. A pure capacitor connected to AC source also does not consume any power because of this cos phi term, where phi was pi by 2 for both the cases. Now then, coming back to fourth one, very simple. The self-inductance means L of a motor of an electric fan. Your household fans, if you look at the back of the fan, there will be a capacitor. And this is your fan, right? These are the three blades. If you open this version, inside this you will find some coil, means inductance coil. Now, the self-inductance of the motor, there is a motor inside due to which the fan rotates, and the motor is made up of a coil, and the self-inductance of that coil is 10 Henry. In order to impact the maximum power at 50 Hertz, this is connected to your household electricity where the frequency is equal to 50 Hertz. In order to impact maximum power at 50 Hertz, it should be connected to a capacitor of what value? If you remove the capacitor from your fan, the fan will not rotate, right? So, what should be the capacitance of that capacitor to have the maximum power from the fan? Means the fan will be rotating with the maximum speed, right? So, these are the four choices given. Let us find out. Now, for maximum power, it should draw maximum current. And means the total resistance, called the impedance, symbol was Z, should be minimum equal to R. Now, we know from theory lessons, the total resistance, that is called impedance, symbol was Z, was derived like this: R square plus XL minus XC square, square root of that. Now, when this will be minimum? If this part becomes 0, then we are adding nothing to R square. If this part has some value, then R square plus something will increase the value of this part. So, in order to minimize this, if your XL is equal to XC, then this part goes. So, square root of R square remains R. So, Z becomes minimum. So, your Z is minimum, that is equal to the resistance if XL minus XC square is equal to 0. And that is possible when XL minus XC is equal to 0. And I take it to this side, so that is omega L is 1 by omega C. So cross multiplying this, I get omega square LC is equal to 1. I am required to find out the value of the capacitance. So let us keep C on the left hand side, take omega square L to the right hand side, it gets divided. Omega is 2 pi nu, square of that into L. 2 is known, pi is known, 22 by 7. Frequency is given at 50 hertz. That is the Indian household frequency for alternating current. And the L value of the coil of which the motor is made of, that L value is also known. So I put the value of L here as 10 to 2 pi 50 square of that. This comes out to be 1 microfarad. Means to this fan whose coil has an inductance of 10 Henry and this is operating at a frequency 50 hertz from your household electricity supply, you have to use a capacitor of this value 1 microfarad so that it will give maximum power by drawing the maximum current from the source. So that is all about. I hope all these 4 less numericals are clear to you. Any doubt, you can still call me, no problem.